let's do this.
Sure.
Who's reading?
An insulated cylinder is fitted with a piston and it contains 0.11 mole of oxygen at room temperature. The gas is compressed from 4 meters cubed to 1 meter cubed, while pressure increased from 10 to 30 pascals. Compare the work done along the 3 paths shown in figure 4.5.
Okay. How do we do this? So what path do you want to follow first?
1.
1? Okay. So for path 1, what would we do? We have to go from A to C to B. So work total will be work from path A to C plus work from path C to B. What's the formula for work? Negative P delta V. So what can you tell me about the work done from C to B? There is no delta V. So this work will be 0. So what's the work done from A to C? So the answer. So it'll just be P, whatever P is, right? So this will be P1. This will be P2. And this will be, V1 and V2. So this will be negative, what is P1?
10 pascals.
10 pascals. And delta V will be, so it goes from 1 minus 4 meter cubed. Yeah, it's V final minus V initial. So it'll be plus 30 joules. Okay, so one of the things that you have to remember, if the answer is given in ATM, you either have to convert it to pascals to get joules as your answer, or you can leave it as ATM in your answers. But you cannot use ATM and give me the answer in joules. That is the surest way to get snails. So the W total is that. Now, what about path 2? So the work done will be from path A to B. What does that graph look like? It is nonlinear. So I will tell you that these kinds of graphs, there are 2 different ones. Okay, guys, pay attention. Every time you see a graph like this, there can only be 2 things that it could be. If it has a slow, steady flow going downwards, it is going to be an isotherm. If it goes down very quickly, it will be an adiabat. Okay? That's the difference. So slow flow will be an isotherm. Immediate drop will be adiabatic. So this curve, what does it look like to you?
Slow.
It's slow. So what is it? An isotherm. Okay, what do we know about work done in an isothermic case? So go back here from last time. For an isothermic case, what is the work done? True, but what is the formula? So what do you think the formula is? The one I have written right here, right? So for isotherms or isothermal case, the work done from A to B will just be negative, what was it? nRT nRT log of V2 over V1. Problem. They don't give us T. But do I know for ideal gases PV equals nRT? So may I replace this with P1 V1 log of V2 over V1? And like magic, I can solve. Why do I use P1 V1? I could have just as simply used V2 P2, right? Because what does isothermal mean? Same temperature. So nRT is the same for final and initial. Does that make sense? Okay, then it's just a matter of plugging in numbers. Guys, make sure you understand where things are coming from. If you don't, ask. What is P1? 10 with a negative sign. What is V1? What was it? 4. And log of V2, which is the final, was 1 over 4. Um,
55.452.
So about 55. Good? Okay, so I'm going to leave you guys to try doing path 3.
This is not the same.
It's exactly the same. It's with different numbers. That is why I'm going to leave it to you to do.